Alright. A little bit of a different filming setup today. We'll see if I can work more in front of the camera on this. But this is the M96, and the last set of videos before I got the M96 were filmed way back in like February. Then I had a break from filming and started working on sewing machines and doing a bunch of other stuff, and my work table has been occupied with different things. But I got the M96 a couple weeks ago, and it's had an hour of runtime, so it's time to take a look at it and see what kind of improvements we might want to make. So I already put the pin head on the needle valve, which is good because this engine likes an adjustment of an eighth turn or less when it's running. And so we'll just pop the valve body off the side here, and these valve body screws definitely, yep, there's the Loctite popping out. They were Loctited in place. The very earliest of these engines were not Loctited, and they had a lot of issues with screws working loose. And that's one of the first improvements I noticed on these Chinese engines, was they started applying Loctite and thread retainer on the tiny screws, which is good because that ET1 engine that I got didn't have any Loctite on it, and the first thing it did when I started it was work all the screws loose and go out of time because none of the set screws were big enough to hold on their own. So I'm just taking a razor to scrape that Loctite out of the screw holes. And we'll wipe that hole out. And then it's got a O-ring here instead of the brass gasket like some of the other engines have, which is nice. O-rings are a bit more reliable on small sealing surface areas like that. So we got the intake side and exhaust side. Those valves are working well, so I'm not going to open that valve chest anymore. We're just going to, and the exhaust spring is what gives the return on the push rod here. Now is this, nope, that. And the push rod is just sat in there, and there's an O-ring spacer on this roller bearing that runs on the camshaft, so that's really nice. And then there's this milled area that is the spot where our detention lever sticks in. So we'll wipe this off. So that's really very nice. There's a small secondary notch here. I wonder if that's a wear spot already. Nope, that was cut in. So there's this tiny notch here that was cut in. Not sure what that's for. Might be clearance for the detent latch. since the fuel line is off, we can just loosen the screw and slip the fuel line out of here, or fuel tank out of here. It's got a plug here. I think that plug is so they have access to help hold this fuel nipple in, because this tank has a solid end this end, but then that end has been soldered in again. So get the new tiny plug is no longer a 1/4 inch plug. So I have to get a 6mm thin wall socket to deal with these fancy new plugs, but I like them. They look really nice on the R18 and here on the M96, so I hope they continue to use them on more engines. The plug was a little dirty, but not bad. There's 2 tiny screws to hold the detent lever in place. And I borrowed the tiny screwdriver out of my tool roll and forgot to put it away. So I need to go find the tiny screwdriver before I can take this latch off and look at it. But there's 4 head bolts here. This cylinder, because it's got the valve chest on the side, this could have been a headless engine design where it's a single piece for the cylinder and this head, and it was all milled up down from the top, drilled out, and this head not have a removable head, and then but that would have required them to make this whole piece out of steel, because it's harder to install cylinder liners in headless engines. So they put a head on here, anodized aluminum, and then this looks like machined steel. They put the head on here so that they could get a liner in there, I think. But let's look. Here we go. No, there's no liner. It's just a steel cylinder, and then they've got a O-ring inset for the head gasket. So they could have made this as a headless engine if they wanted to. But the slight difference from the steel cylinder to the, and since we've got this head off, I'm going to peer around in there and look for scoring. There's no scoring on the left hand or right hand side where the pin on the piston would be, so that's good. And just the head back on real quick. Make sure that you back the screws out to catch the thread on these tiny screws so you don't cross thread them or strip them out by accident. Alright, these are all snug, so we'll give them a little tightening. There. Alright, I need to go find the screwdriver that I borrowed out of my tool roll and very foolishly did not put back. Returned with the screwdriver, retrieved from the place I left it. So, we'll take these two screws out and check out the latch for the governor detention. These are tiny shoulder bolts, which is nice. And then that slides right down. And aha! I have the same style of latch or similar latch as the one that ThomasPCGuru had, where it sets in place like this, and you can see it's got a back rake on the latch, and the latch is supposed to hold on this flat hook area. So there's that groove, and the latch is supposed to hold in there. With a back rake, the pressure here can push the latch backwards out of that groove, and it doesn't latch as like it should. So the way that this latch should be formed, it should have a forward rake so that it hooks in until it retracts. So it looks like what happened is they made these pieces. This seems to be a laser cut steel, and then so it's laser cut steel, but it's too thick to fit in the latch area that was cut in the brass, and instead of recutting this hook area in the brass pieces, they just tapped the latch or hit the latch with a file or ground the latch real quick on a grinder to get it to fit. So I'm sure they just picked the wrong side to get them to fit. I would assume then that when they make another batch of these, they will either modify this latch area to be bigger, or they'll have seen the videos that, well, Thomas and I know they've seen our videos, and they'll know that they should file it from the other side. So I am going to, because I'm getting really good detention on my engine, I think I'm going to just file this straight across instead of try to bend it, because I still have plenty of material here. So I can just file this so it's flat instead of raked back. And then I will straighten that out and flatten it out so it has a little better latching action, and then we'll put it back together. Okay. I have filed on this, and now it is square instead of raked forward. So hopefully that is visible. But now that this latch is square instead of raked forward, it's still about a 1/16 of an inch thick, 3/32. It is small, but not incredibly tiny. So put one screw in. Slip it in place. And then okay. Let's try the other side first. See if I can get this lower screw to start. See about there we go. I do not have a good starting tool for these tiny, tiny screws. So put our first one in until it hit the stop, because they've got a shoulder on them so that they won't over tighten. You still have to feel very carefully though, because obviously you can just strip these little screws out. And then think I've got it. There we go. Perfect. Very fiddly to get tiny screws like that in. But it's started now. And we can just tighten it in until we feel it hit the shoulder. Yep, still moving just fine. Now, with that latch modified, we'll check it out again. But if I want this to run slower, you can see the governor has the spring wrapped around it, and mine already has a stretch in it here. So I can either stretch it some more, or there's a lot of room here if I wanted to drill a tiny screw hole through the ball, and then I could put a bolt and washers on each of these and add weight to these swing arms. But first things first, we'll try that new latch, and then once we've tested the new latch and seen how it runs with the latch profile changed, we'll see whether we want to do anything further. So there's our latch hold, and then lift, let the latch out, and it retracts. So and then we'll have to see if that latch is actually holding open, but for now we'll put our valve body back in place, and I've got the O-ring nestled in the back side of the valve body because that's where the recess was, and that'll hold it in place to press it against the side of the head. Reconnect the fuel line. There. Not the fuel tank. Let's see. Yep, fuel line's connected all the way around there. So this engine has thinner insulation on the high tension lead, and this is one of the old style boots, so it just slips on that high tension lead. It doesn't hold on to it the way the fatter high tension lead, this boot, holds on to it. So that is a little bit of a disappointment, but we'll come up with something if that becomes an issue. So far, it's been no problem whatsoever. These tiny, these new smaller spark plugs just have a O-ring for the gasket. So, like the one on the R18, I just have finger tight compressing the O-ring. This one is a little harder to get a grip on because it's recessed in the head there. So, but you don't have to tighten these down as much as you did the big quarter size plugs. So there we go. I'll get that out and test that new latch.